Hi, it's Mrs. Pope, and today we're going to talk about rational equations and inequalities. Our goal is to solve rational equations and inequalities by eliminating fractions. So this is kind of cool the way we're going to do this. The first one, example 1, we have to solve this. We're looking to solve for x. We have rational expressions because they're all ratios or fractions. And the way we're going to do that is get rid of those fractions. So how we do that is we find the LCD, the least common denominator. We're going to multiply every single term by that least common denominator because that will then get rid of all the denominators. Once we're done with that, we'll simplify and then solve. So the first thing we want to do is find the LCD. So we have to have x plus 3 in there, and then we can look at 6 and 18 and figure out what can both of those go into evenly. Well, 18 would be the smallest that they can both go into. So our LCD is 18x plus 3. So if I take this, I need to multiply by every single one to get rid of the denominators. So I'm going to take 18x plus 3 times my 4 over x plus 3 plus 18x plus 3 times my 5 over 6, and that's going to be equal to my 18x plus 3 times 23 over 18. Now let's see why we did this. Look what happens. 18x plus 3 times 4 over x plus 3, these two are going to cancel out. Now I just have 18 times 4. Here, I can reduce this 6 to 1, reduce this to 3. Now I just have the 3 times 5, or 15 times x plus 3. Here the 18s cancel out, so now I'm just left with 23x plus 3. Now, we don't have any fractions. It doesn't look that hard to solve. It's just a regular equation. So we have 18 times 4, so we're going to have 72 plus 15x plus 45 is equal to 23x. Notice I'm just using the distributive property. Plus 69. So now if we combine all of our like terms and solve for x. So we have 117 minus, I'm doing a few things at the same time, minus 8x plus 45 equals 69. So I subtracted the 23x and I combined the 72, what else did I do? Hold on, 72 plus 15x plus 45. And then, I subtracted 23x. So I got 72, I jumped ahead. Minus 8x equals 69. Excuse me. I went ahead and just did all of the steps. You can do them one by one, but I know you know how to do this already. And then if we subtract 117 from both sides, divide by negative 8, why don't you try it, see what you get, and I'll just tell you the final answer. X is equal to 6. So from here, you should have subtracted 117 divided by negative 8. X would be equal to positive 6. Check that on your own, plug it in, and see if it works. So I'll look for that in your notes. All right, let's solve this one by finding the LCD. So I can see here first, if I'm looking at the denominators, this one looks kind of crazy. So whenever you see that, let's try to factor. You want to always see if you can factor first. What multiplies to 15 and adds to 8? Oh, lovely. It's an easy factoring problem. X plus 3, x plus 5. So now my LCD has to have an x plus 5, has to have x plus 3. This one already has x plus 5, that already has x plus 3. So my LCD is just x plus 5, x plus 3. So I'm going to take this times every single term. So I have 2x over x plus 5. I need to multiply that by x plus 5. Ran out of space. X plus 5, x plus 3. And then minus x squared minus x minus 10 over x plus 3, x plus 5. I need to multiply that by my LCD, which is x plus 5, x plus 3. And that's going to be equal to 3 over x plus 3 times my LCD, x plus 5, x plus 3. All right, let's get the canceling. So the x plus 5, the x plus 5 goes away. So here I'm left with 2x times x plus 3. And let's see here, is there anything? There they are. X plus 5, x, oh, that's lovely. Everything goes away. So I'm left with minus x squared minus x minus 10. Here the x plus 3 goes away. So it's equal to 3x plus 15. I went ahead and distributed that to save some space. So now let's see where we are. 2x squared plus 6x minus x squared plus x plus 10 is equal to 3x plus 15. Now let's combine our like terms. 2x squared minus x squared, it's just going to be x squared, so that's gone. 6x plus x is going to be 7x. Let's set it all equal to 0. I'm going to do two steps at once. I'm going to subtract 3x and subtract 15. So subtract 3x, subtract 15. We should have x squared plus 4x minus 5 equals 0. Now we can factor this into x minus 1, x plus 5 equals 0. So our two answers are x equals 1 and x equals negative 5. What would make those parentheses 0? I do want you to check this on your own, and I'll check that. And I'm going to give you a hint. One works, one doesn't. Come in and let me know which one it is. All right, let's solve this inequality. When we're solving the inequality, we do the same thing just like we did before for the equation until we get to the end. So treat it just like an equation right away. Let's start with finding the LCD. We know we need the LCD between 3 and 4 is going to be 12. And we also need x minus 2. So we're going to multiply everything by 12x minus 2. So 12x minus 2 times x over 3 minus 12x minus 2 times 1 over x minus 2. And like I said, we're just going to make it equals for now. We'll deal with this at the end. Is equal to 12x minus 2 times x plus 1 over 4. So let's cancel. Let's see, we can simplify that, make that 1, make that 4. So then we have 4x times x minus 2. And these cancel out, and 12 times 1, so minus 12. And make this 1, make this 3. So then we have equals 3x minus 2, x plus 1. All right, I know it looks like crazy stuff, but we're going to get there. Here we're going to distribute, so we have 4x squared minus 8x minus 12 is equal to, this we need to FOIL, first outside, inside, last. So you want to FOIL first and then distribute the 3. If you'd like to do that, you could take your time now, pause and do it. Otherwise, I'm just going to give the answer because I know you know how to FOIL. So once you distribute the 3, we're going to end up with 3x squared minus 3x minus 6. We're going to move everything over to one side and set it equal to 0. You can do it one at a time or all at once. Either way is fine with me. But you should end up with x squared minus 5x minus 6 is equal to 0. So if we factor this, we have x minus 6, x plus 1 equals 0. So now x is equal to 6, x is equal to negative 1. So let's see what we do with the inequality. All that has to do is when we graph at the end. So remember, x is equal to 6, x is equal to negative 1. And also, because there's a fraction up here with an unknown variable, we can't have 2 as an answer because if we put 2 in, we're going to get a dividing by 0, and that'll make the whole problem wrong. So x is equal to 6, x is equal to negative 1, x is equal to, does not equal 2. So those are the 3 things that we have to put on this number line. So let's go over to 6, and we're going to break the number line there. Go over to negative 1. Break the number line there, and at 2, break the number line there. So we have zone 1, zone 2, zone 3, zone 4. Here's what the trick is. You need to test something in every zone and see what works. So, and the way you do that is we're going to pick a number over here and test it with the original equation. So I picked -3. Let's see. Or it is negative. I picked -6. So I have -6 from the original equation, and let's write the original equation so we can see it. It was x over 3 minus 1 over x minus 2 is less than x plus 1 over 4. All right, I'm going to pick 6. So 6 over 3 minus 1 over 4, because 6 minus 2 is less than 7 over 4. So if you simplify that, use your calculator or just keep it as fractions, you end up with -1.878 is less than -1.25, and that's true. So we would actually shade that part. All of this would be shaded, because if one value works, all of them will work. Let's try one in the middle. If there's a 0, I always like to use that. So let's try 0 over 3 minus 1 over -2. Is that less than 1/4? Well, we would get 1/2 less than 1/4. That's not true. So we won't shade here. Try a number here, doesn't matter which one. Try a number here, doesn't matter which one. I'm going to let you try those two. Just plug them into the original equation. I'll give you a hint. One section works, one does not. And then you'll just have your number line shaded, and we'll look at that tomorrow to see how we actually write the equation or write the answer. Thanks for watching. This is a long one. And remember, you are responsible for your own learning.